Today we're going to look at some different graphs of polynomials, and we're going to start by looking at these on Desmos. So this first problem here, x minus 1, x plus 1, the first thing we want to do is graph it on Desmos, which you can see I've got here up on the other screen. So the first thing we want to find out is what the zeros are. And you can find the zeros if you look over here. I might need to zoom in a little bit. Just clicking on them, you can see that we have zeros at -1, 0, and 1. So our zeros are -1, 0, and 1. Now, the solutions, if we set this thing equal to 0, the solutions are those exact same things, -1, 0, and 1. The x-intercepts are also -1, 0, and 1. So zeros, solutions, x-intercepts, roots, those all mean the same thing. And then the other thing that we want to talk about with this function is its degree. If we were to FOIL this whole thing out and distribute the x, which we are not going to do that because we don't need to, but if we were to do that, the degree would be degree 3. So notice on this degree 3 has 3 roots, and it looks like that. Now, the other thing that we're going to talk about in a little bit is something called minimums and maximums. So minimum and maximum points happen at the top and the bottom, kind of the hills and valleys of the function. So this has 2 minimum and maximum. All right, so let's take a look at the next one. X plus 3 times x plus 3 times x plus 3 times x plus 3. I have that over on Desmos as well. There it is. And so we can see that it has just 1 0 at -3. So if you want to graph it over here, it looks like this. Of course, you can see it on Desmos there. So the 0 is -3. The solution, if you set this equal to 0, is -3. And the x-intercept is -3. Okay, those all mean the same thing. This one, if you were to FOIL this whole thing out, which would not seem like very much fun, this is a degree 4. All right, let's check out the next couple of problems here, maybe. There it is. All right. Oh, scrolling is getting the better of me. We'll try again, one more time. All right, so the next one we want to look at is x minus 1, x minus 2, x plus 3, x plus 4, x plus 4. I also have that graphed over here on Desmos, maybe. Things are not going well. We might have to start this video over because this is a pain. There it is. Oh, we got it. If you want, you can zoom out so you can see that better. It's got lots of squiggly things going on. But it does have zeros. And the zeros are -4, -3, 1, and 2. Those are also the solutions. Those are also the x-intercepts. And this one, if you would multiply this all out, it is degree 5. All right, let's take a look at this last one. We have x squared plus 1, x minus 2, x minus 3. This one only has 2 zeros. It has zeros at 2 and 3. Those are also the solutions and the x-intercepts. And this one, if you FOIL it all out, it's degree 4. Okay, and if you want to sketch what that graph looks like, something like that. Okay, so when we take a look at these things, I want to go back to that very first one that we saw. Maybe if Desmos will pay attention to me. All right, this one, this was number 1. It is a degree 3, and it had 3 zeros, here, here, and here. Now, it cannot have any more zeros than that. So if you have a degree 3 function, it can have at most 3 zeros because, let me see if I can get that graph where I can draw on it again. If it had another 0 here, that would mean there's another factor up here, and that would be degree 4. Okay, so a degree 3 can only have at most 3 zeros. Now, we can also find something about the turning points. Notice this one had these 2 minimums and maximums. It cannot have another one, because if this turns around again and gives us another minimum maximum, that's going to give us another x-intercept, which would make this a degree 4. So with this, we can make some statements about what we know about our function. So let me get this to the next page. There's something that we can, our big ideas right here. Okay, so if we have a graph of degree n, it has at most n intercepts, x-intercepts, or roots, we can call them roots, whatever you want to call them, but it has at most n intercepts. So if it's a degree 5, at most it's going to have 5 x-intercepts. Write down that that's x-intercepts. If a is one of the intercepts, then that means x minus a is a factor. And the graph of a polynomial of degree n has at most n minus 1 relative mins or maximums. Okay, those are those turning points. So if we have a degree 4, that means at most you're going to have 3 minimums and maximums. In the next video, we'll talk about how to graph without using Desmos.